Today's going to be an introduction to graphing trig functions, and we're going to start with sine and cosine graphs because that's what you were exposed to last year. So we're going to kind of refresh the vocabulary uh, for these sine and cosine graphs, and then later when we graph the other trig functions, these terms will come back. So amplitude. The amplitude, you can think about it as the height of the graph or graph of the sine or cosine function. And to calculate that, it's 1/2 times the maximum minus the minimum, or divide by 2, but then you take the absolute value of that. So your A value, your amplitude, is always positive. The period is how often the pattern repeats itself. And to calculate that, it's always 2 pi divided by your b value. And we're going to look at the standard form of the equation in a few minutes, but it's always 2 pi over b. The axis or the midline, it's kind of like the amplitude, but the difference, amplitude was a subtraction sign. The midline or the axis, you're going to add. And it's not the absolute value. So it's basically just the middle of the function where the starting point. And then the increment. The increment is the horizontal distance between the key points of the function. So when you're plotting these on the graph, your increment is how how big the tick marks are going to be. So usually we're used to each tick mark being 1 in each direction, but with sine and cosine and any trig graphs, it's usually not a good idea to have each tick mark to be 1 unit. And to calculate that increment, you do pi over 2 times 1 over b. So that b value is important, or you could take your period and divide it by 4, and that would also give you your increment. So the sine function, f of x equals sine x, that's the basic sine function, has an amplitude of 1, a period of 2 pi, axis, our midline of y equals 0, minimum, maximum, -1 and 1. And those are going to change when we start transforming this. The domain is all real numbers. The range, though, is -1 to +1, because if you think about the unit circle, the smallest y value on it is -1, and the largest value on it is +1. Now, the graph will always start at the midline, and if sine is positive, it will go up, like this first one here. Our sine graph starts here, and it goes up. If sine is negative, if it's a negative sign, again, it starts at the midline, but then it's going to go downwards like that. So the sine graph always starts at the midline. Positive or negative in front just tells what direction it goes in. And then you can see this wave, the sine wave, goes up and down, and the period is when it starts repeating itself. You might say, well, here to here the y values are 0, but the graph goes down here, but it's going up there. So that wouldn't be the period. The period would be when it starts to do the same thing. So here and here, the y value is 0 and the graph goes down. So this distance would be the period. Now you could pick any point. You go from here to here. This is also a period of the graph, and you could calculate that distance as being 2 pi as well. Tomorrow we're going to worry more about this and writing equations. Today's about graphing. All right, now the cosine function. Everything is the same with cosine, except we start at the top or bottom. What I mean by that is here in y equals positive cosine, we're starting at the top and then it goes down. Our midline is still right here. We go down and then we come back up, And see, this would be our period 2 pi. If it was a negative cosine like this one, you see we start at the negative and we're going up. So cosine doesn't start at the midline, it starts at either the maximum or minimum depending on if we have a positive or negative cosine. Now on the next page, we're going to graph these now, and you can see how A, B, C, and D are evident in these functions. And A and B stretch the curve vertically and horizontally respectively, so that number in front, that A value, that amplitude, will really stretch that graph vertically, and our B value will stretch it horizontally. And notice that B value is factored out, and we'll talk more about that soon when we start shifting left and right. And that D value on the outside translates it vertically, and like I said, that C is a horizontal shift, and it's sometimes called a phase shift because we're shifting that left and right. So to graph, the first thing we want to do is locate the midline and amplitude. And then we're going to calculate the period, identify any horizontal shift, and like I said, we must factor out the B value if it's there. Just like when we were doing absolute value or any functions back in chapter 1, and we have something like that, and I said, okay, to get the horizontal shift, we have to factor out that negative, and it became that. It's the same idea here, but now we're going to be factoring out a value, a number. Then we're going to calculate our interval and then plot points using the intervals. So the first example, we have 3 sine of x over 2. So our interval, our amplitude is going to be the number in front, so 3. So y equals, amplitude is 3. Our midline is y equals 0 because we don't have any plus or minus out here or in front. Our interval, remember we had up there is pi over 2 times 1 over b. Well, b is 1/2. Our b value is 1/2 because we could write this as 3 times the sine of 1/2 x. It means the same thing. So what that does is that's really pi over 2 times 2 over 1, which is pi. So our increment is pi. And then our period, 2 pi over b, which again is 1/2. That's 2 pi times 2 over 1, which is 4 pi. So our function repeats itself every 4 pi. And if you notice, if I take 4 pi and divide it by 4, I get pi, which is our interval. So that in our table, start at 0, and then we're going to go up by our interval. This is a sine graph, so we start at 0, at the midline, 0, and then we go up to our amplitude, 3, back down to our midline, go to our negative amplitude, and then back up to our midline. And this pattern will repeat as we keep going. So we're going to go in both directions when we graph this. So what I like to do is I like to label my axes. So this is going to be 3, negative 3. We're going to have pi, 2 pi, 3 pi, and 4 pi, and then negative pi, negative 2 pi. And we're not going to label all of these. We're just going to label a couple of them from now on, but I just wanted you to see what I meant by the increment. So we start at 0, 0, then we go up, down, down, up. Now that same pattern goes to the negative, so we would go down, then up, down. So our graph looks like that. Now for letter B, it's a cosine graph, so that means our graph is going to start at either the top and bottom, and because it's a positive 2, it's going to start at the top. So our amplitude again is that number in front, 2. We don't have a plus or minus anywhere, so y equals 0 is our midline. Our b value is 6, though. So what that's going to do to our interval, pi over 2 times 1 over 6. So our interval is actually pi over 12. And then our period is 2 pi over b. So it will be pi over 3 as our period. So now our interval, so we start at 0, and we're going to go up by pi over 12. So 1 pi over 12, 2 pi over 12, which reduces to pi over 6, 3 pi over 12, which is pi over 4, and then 4 pi over 12, which is pi over 3, which is what our period is when we calculated that. So being able to add and reduce our fractions is going to be essential because this takes a lot of time, writing it out and reducing the fraction. You want to be able to do that in your head. Now we're going to start at 2, or positive amplitude, go down to 0, then down to negative 2, back up to 0, and back up to positive 2. So then, I'm going to stretch out this graph a little bit and put 2 up here, negative 2 down here, and then our increment again was pi over 12, so pi over 12, negative pi over 12, and instead of writing it for every marking here, just know that it goes up by pi over 12 each time. So we start here, and then we go down, down, up, up, and the pattern repeats itself. So our graph will look like that. All right, now let's look on the next page where we're going to be shifting. If we look at example 2, we have 2x minus pi in parentheses, but we have to factor out that 2 in order to get our shift. So that's going to be the first thing I do, 3 sine, and I'm going to factor out a 2, which is going to give us x minus pi over 2 in parentheses like that. So our b value is 2, but our horizontal shift is going to be pi over 2 in the right direction. We're going to shift right pi over 2 units. So let's look at this. Our axis, y equals 0. Our amplitude is 3. And then our interval, pi over 2 times 1 over b, our b value is 2. So pi over 4 is going to be our interval, and then 2 pi over b, which again is 2, is our period. So our period is pi. So, but instead of starting at 0 in our table, that pi over 2 there means right pi over 2. So our table, instead of starting at 0, is going to be pi over 2. Now we're going to be adding pi over 4 each time. Well, you can already see that these are not common denominators, so we have to address that. So pi over 2 plus 1 pi over 4 is 3 pi over 4. Then we have 4 pi over 4, which is pi, 5 pi over 4, and then 6 pi over 4, which is 3 pi over 2. And you might say, well, my ending value is not the same as my period anymore. Well, that's because we were shifted pi over 2 to the right. If I were to take the period pi and add pi over 2, that gives me 3 pi over 2. Right, now the y values. For the y values, we are starting at the midline because it's a sine function. So 0, then up to the amplitude, which was 3, down to 0 again, the midline, then down to -3, and then back up to the midline. So we'll put pi over 4 there, and then that'd be 2 pi, or pi over 2 right here. And if we go backwards, that'll be negative pi over 4. So we started at pi over 2 comma 0, and then we go up. Oh, I didn't do the y-axis, so let's do that. 3, -3. Now you see all of our points aren't going to fit. That's okay, because we're just going to follow the same pattern going backwards. Now you could have chose to make each tick mark pi over 4, but I always like to kind of spread it out a little bit and have each tick mark be the increment, and I usually use 2 grid marks for it. That just spaces things out a little bit and makes it easier to see. All right, now with letter B, we have a vertical shift because of this 2 right here. Remember, you could rewrite this as -2 cosine of 2 pi x over 3 plus 2. So there's actually a lot going on in this problem, and let's put those in parentheses just to further emphasize that plus 2 is a vertical shift, not a horizontal one. So now our midline, or axis, is y equals 2. Our amplitude is also 2, but because it's negative, now we're going to start at the bottom. Now let's do the work to calculate our interval and period. And we have some space here for the work on some of these problems, like especially this one where it's going to be a bit more complicated. Our interval, or you could do the period first, it doesn't matter, because remember, if you calculate the period, you could divide that by 4, and that will give you the interval. So our b value is actually 2 pi over 3. So to calculate the interval, 1 over 2 pi over 3. So we're going to multiply by the reciprocal. So it's going to be 3 over 2 pi. 3 over 2 pi. So the pi's would cancel out, and our interval would actually be 3 over 4, 3/4. Now for our period, you could take your interval and multiply it by 4 to get your period. That will be one way to get it, or 2 pi over 3, which is 2 pi times 3 over 2 pi. The 2 pi's would cancel, and you're left with just 3. So now in our table, we're starting at 0, and our interval is 3/4. Notice there's no pi in our interval. So we have 3/4. Then we have 6/4, because we're adding another 3/4, which is actually 3 over 2. Then we have 9/4, we can't reduce that. And then we have 12/4, which reduces to 3. And because we have no horizontal shift, our period and their last x value in our table are the same. So now for our y values, again, because it's cosine and negative, we're going to start at the bottom, but we also have a vertical shift of 2 because our axis is at 2. So there's a couple ways you could do this. You could write out your y values without the shift and then make a third row. And I'm going to do that just for this problem. So we're going to have -2, 0, 2, 0, -2, and then just realize, okay, now I have to add 2 to all of these because of our midline. So it's going to be 0, 2, 4, 2, 0. And then you could ignore that. Or if you can do that without writing that out, that third row, if you could just recognize, oh, okay, I'm going to add 2 to all of my y values and just do that from the beginning, that's fine as well. All right, so our midline was at 2, and then our amplitude was 2, so we're going to go up to 4 and down to 0. And then our interval was 3/4, so I'm just going to do 3/4 for each of these markings and -3/4 for each of these markings. And we started down here because it's negative cosine. We're going to go up and come back down, so our graph will look like that. So the more that you do these, the easier that it will become. The biggest thing that I've noticed students having issues with is that our tick marks are not consistent through all the graphs. Like in this problem, every 2 boxes is 3/4, and each of my tick marks in green represent 3/4. Where in this problem, each of my tick marks, or the pink lines I drew, represented pi over 4. It's the same number of grids, but each value is different depending on the problem. So if you can wrap your head around that, these problems become so much easier. So thanks for watching the video. Make sure to like it and subscribe.